All right, so here we are, 5.3, adding polynomials. You'll see that in your notes. You should have this exact page in your notes there. And we are going to talk about combining like terms like we did yesterday. We talked about what are like terms, which ones could we combine. And adding polynomials is simply a fancy way of combining all the like terms. But it's set up just a little bit differently. You'll see it just a little bit differently. We're actually going to have a sum like this, a sum which is adding polynomials in groups. So we're gonna see them like this a little bit. We're still gonna refer to algebra tiles. Okay, we're still gonna refer to algebra tiles, but you don't have to use algebra tiles for all these questions. And in fact, algebra tiles are kind of a bridge. I want you to be able just to look at the expression of the polynomial and be able to add and subtract and do all the operations without algebra tiles. That's the goal. So some of these questions will have algebra tiles, and you're encouraged to use algebra tiles if it helps you to make sense, it helps you to get the correct answer. I'm totally fine with that, okay? So let's take a look at this. To add polynomials, as I said, you just simply need to combine like terms, okay? So we're just combining like terms like we've already kind of started doing. So in algebra, so on the left side of your notes, you'll see that's kind of the algebra method. That's what it's going to look like with just the expressions there, just the terms. On the right side is going to be the algebra tiles. So the sum in algebra language looks something like this. This will be the first one. So negative 3x squared minus 2x minus 4. That's our first polynomial. Okay, that's the first one. Over on the right, that expression is represented by the algebra tiles over here. So I have 3 negative x squareds right here. I have 2 negative x's right here. And I have 4 negative 1's. Okay, so negative 4. So the algebra tiles on the right correspond with this first expression on the left. Okay, so we are adding, and we're going to be, today is just all adding, so that's going to be good. We're adding an x squared, so that's this one right here. That's a positive x squared. A negative 3x, so 3 negative x's. And then plus 5 single one square tiles. Okay? So you can see how it matches up on both sides, hopefully. So algebra method, what we want to do is we want to remove the brackets. Okay? And with these brackets, all right, we are basically saying I have 2 polynomials that I'm adding, but we want to focus on the like terms and getting those all together. So it's kind of like this. If there's a group of students that walk into a classroom and kind of stand in the back, and another group of students walk into the classroom and stand in the front, that would be like these 2 groups, okay? There's group 1 and group 2. And if I say as the teacher, it's like, okay, everyone, I want all the grade 9s to go on this side and all the grade 10s to go on this side, assuming that there's only grade 9s and 10s in these 2 groups. Well, then you would split off from your groups and go to the appropriate spot, right? So some 9s from the back and some 9s from the front, they would all go to the side. So that's kind of like removing brackets and grouping like terms. So removing brackets says, okay, I'm able to mix anything that is the same. Okay, remove brackets. And it's just as easy as when you add a group of terms, you don't have to worry about changing anything. You simply just erase the brackets. When you're adding things and they're grouped in brackets, you can just remove the brackets because you are adding an x squared and you're adding a negative 3x and you're adding a 5. So you don't have to think differently. Just remove the brackets. When you're adding, just remove brackets. Okay? And now we can group the like terms. So again, algebra on the left side, you'll notice that the x squared term and the x squared term are now together. And the x term and the x term over here are now together. And the constants are now together. Okay? And in algebra tile world, what we might want to do is arrange them so that we have some 0 pairs beside each other. So remember, in gathering like terms with algebra tiles, we want to just eliminate the 0 pairs, okay? The opposite of the same shape. So this is going to be gone. That's going to be eliminated. That's a 0. And I have 4 positive tiles here and 4 negative tiles. Those are also gone. So we can 0 those off. And whatever's left over is going to be the simplification of this polynomial sum. All right? Now, I know I'm using some big words, maybe, but I am going to try to use the proper terminology as much as I can in grade 9 and in grade 10, 11, 12, all the way through, so that by the time you get to grade 12, and I'm going a little bit faster with a little bit more difficult calculus material, when I say a sum of the polynomials, you know exactly what I'm talking about. You don't have to think about it, okay? It's not new for you. So these words might be a little bit big, but I'm going to try and repeat them and explain them and be very thorough with you so that you know what I'm talking about, okay? Because the literacy in math is really important, okay? You got to know that a sum is adding. You got to know that a difference is subtracting. A product is what? Anyone know? Multiplying, yes. And a quotient is dividing. Very good. Okay. You guys are a pretty smart class, so I'm not worried about you at all. All right. So I see algebraically here now, I can actually do some combining of the coefficients. Remember? So when we have like terms and we don't have pictures of tiles, I look at these coefficient values. So that's a -3 and a +1 x squared. So what's -3 plus 1? That's going to be -2. And of course, these are the x squareds I'm talking about. So those ones are combined now into this. I have a -2 on this x and a -3. So think about those minus signs as just regular negative integers. That's a good way to do it. So -2 and a -3. When we combine those, what do I get? Okay, I heard somebody say 1. I heard somebody say 5. Think about this. If you're unsure, think about a number line. Okay, this is how we do this on a number line. Here's 0. I'm going to start at -2 because that's the first one I see, and then I'm going to take away 3, or I'm going to add another 3 units in the negative direction. So I go 1, 2, 3, and this is my answer. So that's going to be -5. Okay, everybody see that? Number line's good for this too. When you start to subtract negatives and do all that fancy stuff, sometimes the number line can get a little bit confusing, I'll be honest. I don't really like the number line for that. It's just easier to remember some rules. But when you're adding things like this, it's pretty straightforward. Okay, so let's get rid of this. All right, and that's going to be, I said -5x. Good. And then finally this one here, -4 plus 5. If you want to think of the number line again, start at -4 over here and add 5. We get to 0, and then we go 1 more, and that's going to be
1.
+1? Okay. So let's see if that matches up with what we see on the algebra tile side. Okay. I have left over 1 -x squared and 2 -x squareds. Boom. Got it right there. I have left over 1, 2, 3, 4, 5 negative x's. Boom. Got it right there. And I have one single solitary little +1 there, and that's what I have there. So does everyone see how that matches up? All right. So you've got a lot of tools in your tool belt here. You got algebra tiles, and now you can see the like terms, and then just add the coefficients or combine the coefficients. We're good. And of course, there you go. There's your answer algebraically, same as what we have, and algebra tile wise. All right. Let's do another example together from scratch. We'll do this algebraically, because that's what that's the goal, is to be able to do this without drawing, algebra tiles all the time. So let's see what we got here. Very much the same as the very first example. So add algebraically, I'm going to remove the brackets. Now, when I take the brackets away, do I have to change signs, or do I have to change anything around, or what's the rule about removing brackets again? Somebody help me? Just erase them, right, when we add? Okay, when we add, you just remove the brackets like they're not even there. So I'm going to rewrite this. -2x squared minus 3x, and I'm just going to keep that plus sign, and I'm just going to take away that bracket so it looks just like this. No problems. Okay? That's what you can do when you add. Okay, step 2. Now, in the future, when you get good at this, you don't have to do this step. But now I want you to. So I want you to pull all of the like terms, and I want you to group them together. So I see that I have an x squared term and an x squared term, so I'm going to write those together, -2x squared, and I keep the sign, right? I drag that sign along with it when I move it. So -2x squared plus x squared, that's an excellent group. Are there any other x squareds there? No, just those two, so good. I can move on to the next one. And I have -3x and a +2x. They're kind of already together, so that's great. So -3x here and a +2x. I can just write that in my polynomial as minus 3x plus 2x. Awesome. Okay, so I've got them grouped. Now I combine like terms here, right? Combine like terms. So I have negative 2x squared and I add 1x squared. What's negative 2 plus 1?
Negative x squared.
It's negative 1x squared. And because it's a 1, we generally don't write that 1 in there, okay? So for example, if you wrote this right now, I wouldn't mark it wrong, but we want to start to learn that this is not the way we do it in math, okay? Just kind of like when you say, when grandma says, how old are you now again? What grade are you in? Well, grandma, I'm 1 times 15 years old and I'm in 9 times 1 grade, right? We don't say that, right? So you don't actually have to include that in your speech. You don't have to write the times 1 in math either. So we'll just eliminate that, and this is the way we'll go. Does that make sense? Okay? Do you like my grandma voice there? I can actually do a really good old person voice, partly because I'm kind of old myself, but I can do a really good old person voice. So that might crop up in a bit. All right, what about the x's? So I've got negative 3x and I've got a plus 2x. So I've got a negative 3 on the negative side here, and I add 2. Where does that get me to? All right, careful now. The negative is bigger than the positive, so that's a minus. It comes up as a negative 1 or minus 1x. So I don't have to write the 1. Negative 3 plus 2. Everyone agree with that? You okay with that? Okay. Yeah, and rearrange, combine. And we're pretty much done there. Now we're done. So we don't have any more combining to do. You can just leave it just like that. Okay, how was that? Was that like 5 out of 5 easy? Was that 0 out of 5 the most difficult thing you've done all day? Well, this is first class, so it might be the most difficult thing you've done all day. Where are we at? 5 is pretty easy? Okay. What do you got? Fingers? Let me see fingers. 1, 2, 5. Okay. I'm seeing lots of fingers. Good, good. Lots of fingers. All right. Okay, let's see. What's on the next page here? What's on the next page? Okay, so let's talk about adding polynomials vertically and horizontally. So that's interesting. You'll see in your textbook that you can add polynomials sort of the traditional way vertically like this, like you would, like you remember in grade 3, 4, whatever, you added like, 3-digit numbers together and you put one on top of the other, right? And you did the columns. So you can do that with polynomials as well. It's going to look a little weird, but that's something you can totally do. So let me make this just a bit bigger for you. Okay, so the blanks are you can add polynomials horizontally and vertically. So we're going to write those in. Horizontally and vertically. So horizontally is just the same as we've been doing. You remove brackets, you gather like terms, you combine the coefficients of the like terms. And that I won't need to go through this at all, really. I don't think. We just did this. Here's another example of that. Also, just I guess notice that if you only have one type of term, don't freak out. Don't say, oh, this I don't know what to do now. If you just have one n squared term, that's what remains. That you just leave it alone. It's just that's what stays. Okay. If you have 2 or even 3 or 4 or 5 like terms, then you would add them all together. But if you just have one, then just leave it. So this same example written vertically over here, what you would do is you would put all of the like terms in the same column. Okay, so you might have to rearrange your terms a little bit. We've done that before. But best way to do this is to make sure that in columns you have like terms. So here's the two constants, right? Here's the 2 n terms, and there's the one single solitary n squared term. So if you keep them in columns, this is going to be real easy. And yes, you will, in math classes to come, you will have to put polynomials vertically like this. I'm thinking what comes to my mind is we will do long division with polynomials. Like you do long divisions, like 100, 110 divided by, 7 or whatever. We'll do that with polynomials too. But I think that's in grade 11 maybe for you, so you don't have to worry about that for a while. But the columns like this will be very important come then for sure. That's the first thing that comes to my mind. All right, so -6 plus 14, that's going to get us all the way to 0, and then 8 more on the other side of the 0, so that's plus 8. And 1n plus 7n is going to give us 8n, and then see how I'm doing that vertically. And that's just another way to show your work. Okay. This example 2, we're going to do this both horizontally and vertically. So let's go ahead and do that. Again, lots of practice is what we need here. So first step, I know I'm adding, so I'm just going to drop the brackets. Okay. So I'm going to go 2x squared. We'll do this horizontally first. I'm going to go a little bit faster now because I think we're kind of getting the hang of it. Okay, if I drop the brackets and I have a plus minus x squared, this is something we haven't seen yet. What do I do with this? Is that even okay? What should I do there? What does this mean? Should I have two signs like that right in a row? No, probably not, right? I shouldn't have two signs in a row. So if I add a negative and I remove the brackets in between, what should I write that as? Anyone know? Yes, it's the same as a minus. Very good. So if this is the case, what you should do is see, hey, I'm adding a negative. I shouldn't have two together. That's the same as subtracting. So that's one little wrinkle when we remove the brackets. Good job. Good job. Everything else can stay the same. Plus 7x and minus 3. So I didn't change any signs here. I just kind of like rewrote this, simplified this, right? Okay. Okay, good job for that. All right, group-like terms, 2x squared minus x squared. I'm going to put plus 3x plus 7x. And I'm going to put minus 2 minus 3 together. All right, the x squareds are together, the x's are together, the constants are together. So 2 minus 1 is just 1, so that's an x squared there. A positive 3 plus 7 is going to be plus 10. That's 10 x's. And negative 2 minus 3, that is minus 5. So I've got x squared plus 10x minus 5. Everyone agree with that? Are there any errors there that you see? There might be an error somewhere I'll do on the screen. To be honest with you, over the years, I'm a little less concerned about doing everything absolutely right all the time. I don't make many mistakes because I've done this stuff so much, but I just kind of like go, and sometimes I get distracted with you guys and your questions, and I come back and up and down, and I miss a sign or something. Honestly, I don't worry about that anymore because guess what? You guys are my double check crew. You guys are my team. Okay, so if you see something up there that I might have done wrong, please let me know about it. Ask about it. Say, hey, did you miss a negative sign there, Mr. Maxwell? And I'll look and I say, yes, I did. Very good. So I don't really concern myself with double checking my work all the time. That's your job. Okay? So that's how you guys help with this teaching stuff. Okay? Awesome. So if I do make a mistake, please ask about it. And you know what? If it's not a mistake and you thought it was, don't worry about it. I'm glad that you're paying attention and you're brave enough to ask. So I have a hand up now. Did I make a mistake or do you have another question?
How did you get x squared for your answer?
Oh, how to get x squared? Okay, thank you for that question. So let's go back to this spot right here. And these are my like terms of x squareds. I have a plus 2, right? I have 2, and I take away 1. Oh. Whoops. I won't leave that finger up, sorry. I'll take away this finger. And that was close. I did not mean to do that. I'm so sorry. But at least it wasn't this way, right? Then that's a little bit worse, right? So no, sorry about that. That's a mistake. See, I make mistakes all the time. Okay, so I'm going to take 1 away. I'm left with 1, okay? You got it? All right. See, you have fun in math class, okay? Guess what the teacher did to me today? I'm serious. All of us, yeah.
It would be better if you were videoing.
Yeah, and actually I am. I am videoing that. Yeah. So we're definitely recording that. So you can look at that later if you want. Yes. This will be live for the world to see. Okay, real good. Yeah. I might edit that out. We'll see. But actually, editing these videos is a lot of work. So a lot of times I just don't edit them out. So you'll have to check later today to see. Okay. Yes. Yeah. Okay. So let's do this vertically. And I'll try not to, be offensive to you when doing this one. So I'm going to do this. I'm going to do 2x squared plus 3x minus 2. I'm going to write the first one kind of on top, okay? And I'm adding, so I'll put a little plus sign over there. Now I have to make sure that I rearrange my terms, if I need to make sure that the like terms are in columns, right? So I have a negative x squared that I will write underneath this one. And I'll put my little line there so you can kind of see where this is coming from. And then I have a plus 7x. Okay, so I'm going to put that here, 7x. And minus 3. All right, so all the like terms are in columns together. And yeah, this is just so simple. -2 plus a -3. That's going to be -5. And you can start from wherever you want. Doesn't matter, actually, if you start from the left side or the right side. We usually start on the right side when we add, vertically, right? So we can do that. There's going to be you don't have to carry anything over, though. You don't have to, carry the 1. You don't have to do that. You don't do that at all. So 3x and 7x, so notice that this is plus 10x. I didn't, write down a 0 and carry a 1 or anything like that. You don't have to do that. Okay? Yeah, you like that? Okay. So 2 minus 1, or 2 plus a -1, is going to be just 1x squared. I'll try not to write the 1 there to be proper, and I get the same answer. So you should get the same answer whichever way you do it. How's everybody feeling about that? Good? Yes?
Is the vertical way the faster way?
Is the vertical way the faster way?
Or would it just be the easier way?
I don't know. I think we're probably, as you move through math, you're not going to be doing this a lot. You won't have to do this vertically a lot. I think that it's just helping you to see the like terms. That's why they kind of we're teaching you about this now. But to be honest with you, you're just going to probably do the horizontal, in future math, like when you get, when math is your job, when you get to be a math pro, you're not going to do the vertical probably. But right now it's just helping you maybe notice the like terms, because they're kind of grouped vertically. So it might be easier to see. Good question though. Anything else? All right, let's keep going. Write this polynomial. Write a polynomial for the perimeter of this rectangle. Okay, perimeter. Who remembers what perimeter means? Can someone volunteer to give me an explanation there? Is that a hand? No. Perimeter? Yes? Okay, I kind of like half of what you said. You said the area around the shape. So if I'm being really picky with the words, area means the space inside, but around the shape is pretty close to perimeter. So what you probably mean is you mean the sum of the distance around the outside. Okay, so you mean the distances around the outside. Area, I'm not sure I like area in that explanation, but thank you for offering that. We learn a lot more when we make mistakes than when we do everything right. You know that? We learn a lot more that way. So that's good. Thank you for that opportunity to correct that. Okay, so what does this mark mean over here? I'm kind of confused. Can someone help me what this little mark means? Yeah. It means it's equivalent to the other side that has the same mark. Thank you very much. So I'm just going to show that by doing this right here. Okay? So those are both the same length. That's exactly right. You'll see that all the time on shapes. That's what you know. They're the same. And then this one over here, I guess, would be the same as this one up here. This has got two hash marks there. So this is going to be 3x plus 2. So that means that this is a rectangle, right? We've got 90 degrees there. Well, actually, it doesn't necessarily mean that, I guess. It doesn't mean that, but we can assume that that's a rectangle. It could be a parallelogram. So it could be just off 90, and the opposite sides could still be the exact same length, okay? But, so what we're going to do is we're going to add all of these up. So I'm going to go 3x plus 2. And I'm adding them, so guess what? I probably don't even need to write my brackets. You can, but let's save a step. Plus 2x plus 1. Plus 3x plus 2. I'm just going around the outside. Plus 2x plus 1. Okay, did I get that right? 3x, 2. Got 2 of those. Got 2 of those. All right. All right, so gathering like terms, I've got 3x plus 2x plus 3x plus 2x. And the constants, I've got plus 2, plus 1, plus 2, plus 1. Awesome. This is going to be real quick. You guys are so good at this. So 3 plus 2 is 5, plus 3 is 8, plus 2 is 10. 10 x's. Yep.
Could you just put 3x plus 2x in brackets times 2?
Yes, you could. Yes, you could. And that's where we're going to be moving to shortly. That's kind of multiplying. We're going to distribute, multiply polynomials and stuff like that. So you're exactly right. You could group these two together and say, hey, there's 2 times this. That is totally true. You could do that. 2 times this, and then 2 times this one right here as well. That would be the exact same. but I'm just going to do it this way first, but you're right, that's exact same. So let me finish this. So 2 and 1 is 3, and 2 and 1 is another 3, so looks like 6 there. Okay? So 10x plus 6. Everybody okay with that? Now there were some hands up at the back there. Good question?
Does it matter which way like you put the numbers after you like did like after you added it all?
Okay, do you mean in the final answer? Does it matter which order you
Yeah.
put them in? Technically not really. No, technically not really. We're just adding apples and oranges, so oranges and apples are still the same thing. You'll find generally, remember the descending order lesson the other day, where generally if you have a polynomial, you write the term with the greatest exponent first, and then the next largest, and then so on. So there is a way to generally do that, and usually the constant is at the end, and then the other terms with variables are in descending order. That's generally the way we do it, so descending order. So that's the way you'll see me do it. I'll just default to that, 10x plus 6. But if you wrote 6 plus 10x, it wouldn't be wrong. Okay? It wouldn't be wrong right now. Good question. Anybody else? All right. We're getting, you guys are good. You guys are really good here. We've got a lot of practice to do next on the next page. So that's going to be kind of most of your work for today. So we've got a lot of practice there next page. But let's do this one real quick. And this one's a little bit different because it contains more than one variable. So we're going to spend a little bit of time on this one, and then I'm going to let you guys do some practice. So adding polynomials that contain 2 variables is a little bit of a different story. A lot of the rules are the same though. Like they're all the same. So what I'm going to do is I'm going to drop the brackets, and so I'm just going to erase these, sort of. I'm going to get rid of those. And because I'm adding a negative, guess what? That's just like minus, right? So this might look a little bit weird, but I'm just dropping the brackets to save us some time. And then I'm going to combine like terms. So this will be a good like term workout here. Where's another term that's like a squared? Do you see another one anywhere?
5a.
Okay. I heard 2 answers. 3b squared. Now those 2 are not like terms, because they don't have exactly the same letter or variable with the exact same exponent. They have the same exponent, but you have to have the same letter as well. Okay, so these are not like terms, but that's pretty close. The other like term would be way over here at the end. That's an a squared term as well. Okay, I don't see any other a squared. So let's go 2a squared plus 5a squared. I'm going to group those together. Okay, those are taken care of now. And you can do this literally what I'm doing, just kind of stroke off the ones that you've already kind of gathered and taken care of so you don't lose track. Let's take a look at those b squareds now. So let's do 3b squared. Is there another b squared? Right here. So I'm going to do plus 3b squared minus 4b squared. So those are taken care of now. All right. Let's do a terms. Okay, so here's an a. Is there another a term somewhere? Right here. So I've got plus a minus 5a. And I've got rid of those. Okay, so b term. There's a b term. Is there another b term? Oh, over here. So I've got minus 3b plus 6b. So those are gone now. And I've got an ab, negative 7ab, and a plus 3ab. So those are like terms because they have the exact same combinations of variables and exponents on those variables. Minus 7ab plus 3ab. And that's gone and that's gone. Do I have any left? Nope, none left. So I've got everything sort of reorganized properly. And now I can just go ahead and gather the like terms. So those 2 are going to be 7a squareds. These 2 are going to be what? 3 minus 4 is... It's a negative 1, or I'll just write negative. Okay, I have no idea what happened there. A glitch in the matrix. Oh yeah, and now it won't let me stay down here. Okay, so negative b squared, right? Negative 1b squared, good. Here's the a term, so plus 1 minus 5. What's 1 minus 5? It's a negative 4, so we're going to go negative 4a. And here's the b term, so negative 3 plus 6 is plus 3b. Awesome. And now we've got finally the ab term, so negative 7 plus 3 is negative 4ab, okay? If you're struggling with knowing in like mentally adding and subtracting integers, you need to practice that, okay? Try not to refer to your calculator all the time. I still see grade 9s. You gotta be careful with the calculator. You shouldn't do negative 7 plus 3 on the calculator. If you absolutely have no way of getting that answer, use your calculator for now, but come talk to me, okay? Use the number line as a crutch, but try and do as much of this in your head as you can, okay? Because you need to have these addition, subtraction, multiplication, division. Those facts you have to have them like this, okay? In order to be successful in math, okay? So please work on that. If you're having trouble, come talk to me. All right. So do I have, now what I should do is I should look again to see if there are any other like terms that I missed. If I missed something, if I have two a squareds left here, I have to kind of simplify those. I have to keep going. But if I don't have any more like terms that I see in that list and everything has been combined, then I'm good to go. So are you guys happy with this list here right now? Again, order doesn't matter. It gets a little complicated when you have multiple variables and all that stuff. So order doesn't matter really at all. Just don't worry about it as long as you've got the right coefficients in front of the right terms. Okay? All right. Everybody's good? All right. We have shortened class today, so we have about 10, 15 minutes here. Let me see, maybe less, maybe 10 minutes. So on this page, you'll see that there's a lot of practice, okay? So this is the, I'm not going to give you an assignment here. Well, I might give you the assignment because you don't have school tomorrow. I might give you the assignment to start working on. But I think the plan is for us to have Monday to finish off the assignment. So if you can get this taken care of today, and then maybe on the day off tomorrow or the weekend, you can work on this assignment, which I'll give you later. But you will have Monday's class to finish this. So let's take a look. All right, sum of integers. Oh, look at that. I just mentioned that you need practice with this. So here we go. Let's get some practice. This is great. I'm just ahead of myself even. Okay, so 9 minus 7 is 2. Good. So I have 9. I take 7 away. I've got 2. Negative 9, and this is sum, so we're technically adding everything. So negative 9 plus negative 3 is the same as negative 9 minus 3, right? Is negative 12. Okay, so again, that's okay. That's okay. It's okay if you get the wrong answer here. We're practicing. That's what we're practicing for. So again, you have negative 9. Start at negative 9 on the number line. You take 3 more away. You get to further away from 0, so negative 12. Negative 9. Okay, here's 0. Negative 9. We're going to add 5 now. We're coming closer to 0, so we're at negative 4. Good. Negative 4 plus a negative 8, or negative 4 minus 8 is negative 12. Good. 12 plus 21.
33.
Good. This is the way I do it. I add up the 10s first always, and then I add up the 1s next. And I think, well, isn't that the opposite of the way you do it? I always add up the 10s first, and then if the 1s are greater than 10, when I add them up, I just kind of like add another 10. So this one is 20 and 10, right? So that's 30, and then 2 and 1 is 3, so it's 33. 33. You may have a different strategy than that, I don't know, but that's the way I do it. 20, so negative 20 plus 15, I'm at negative 20, I'm coming closer to 0, so I'm going to be at negative 5, because the positive is smaller than this negative number, so I'm still in the negative area, negative 5. All right, everybody okay with that? Good job, good job. Okay, so I'm going to do some of these, I'm going to let you do others. I'll probably do the first row with you. I'll do the first row with you, and then I'm going to let you guys go ahead with the other rows. So first row, sum of the polynomials, awesome. Doesn't matter where you start. I'm going to start over here. 3 and 6 is 9, and that's going to be a plus 9. Don't forget your sign. And 7x and 2x is 9x. If it's a positive, you don't have to write the positive in front. But obviously if it's a positive kind of in the middle or at the end, you do have to write the plus there. So you can't just do this, right? You can't just say, oh, that's 9x 9. There's got to be something in between there. Okay? All right, this one, 2q plus 11q is? That's 13q, and that's a positive, so we're going to make it a plus there. 7p and 4p is 11p. So 11p plus 13q. You guys okay with that? All right. Now, if you want to start on the left side, I'm okay with that too, if you want to start on the left side. So let's do the left side start here. These are like terms. They're both GH terms. So 31 and 20 is 30 and 20 is 50. 1 and 0 is 1. So 51, GH. And then a 3 minus 2 is plus 1. I won't write the 1. G squared. All right, you getting it? If you have a question, let me know. Over here, x cubes are in line there. That's a 2, and this is understood to be a 1 if nothing shows up. So that's going to be 3x cubed. Negative 6 and negative 5 is minus 11 x squareds. 3x minus 6x. That's going to take me into the negative area, and I've got negative 3x. And negative 8 plus 4 is going to get me closer to 0, and I'm going to end up at negative 4 there. Okay, how did that first row go? 5 out of 5? Or thumbs up? Okay. I'll substitute thumbs up for 5 out of 5 too, because a lot of you are giving me thumbs up, so that's good. All right, 5 out of 5. Awesome. Okay, excellent. Just don't give me a 1, okay? Don't give me a 1, all right? Don't give me a 1, all right? Don't give me a 1, okay? Please, no ones. This finger for a 1, thank you. This one, just this one only. Okay, it's your favorite one? Okay. All right, okay, you guys go ahead and work on these. Yeah, I think I can do 15. Can you do 15?
No.
Oh, is that why you asked? Okay. You're at 15 already? Okay. Yeah, sure. Let's see. I was asked about 15. So what is 6 minus 6? That's 0. So you don't have to put anything. You can put 0x squared if you want, but that's a good question, actually. You don't have to put anything. You can just leave it blank. So 0x squared is really like just nothing. And then 3 minus 3 is also 0. So you can put plus 0. So if you have two 0 terms, the answer is 0. Yeah. It's just 0. Yeah, you just put 0. Don't leave it blank. You have to put 0 as an answer. If you leave it blank, I'm like, did he even do this question? But yeah, you just put 0 as your answer. Perfect. Yeah. That's a great question. Anyone else run into anything that they want to ask about before I let the lions loose on this here? Just go ahead and devour this. Awesome. I will throw up some answers to random questions up here before the end of class so you can check before you go. All right? But I want you to have this done for Monday, and I will show up the assignment for this section too before the end of class here. Okay, question about number 11. So this is a 1a plus 12a. So that's going to be 13a. And then a 2 plus, if there's nothing there, remember that's a 1. So 2 plus 1 is 3h. So it should be 13a plus 3h. Okay, great job today. Here's some random answers again for your worksheet. You can check those out. And we'll see you guys on Monday. Okay, be ready for your quiz on Monday.
Because I was looking at your website yesterday.